Hello everyone. In this video we're going to be solving a very interesting equation. We have y plus e to the power y equals x plus e to the power x. And we're going to try to solve for y. And you might be asking, why are we solving for y? There's no particular reason. If you want, you can also solve for x. But what kind of equation is this? Can we use Lambert's W function? Let's give it a try. So I'm going to start by natural logging both sides. So can I just ln y plus e to the y and x plus e to the x, and are they going to be equal? Yes, if a is equal to b, then ln a is equal to ln b, because ln x is a function. All right, what is the log of a sum? Nothing. It's the log of a sum, nothing else. If you had a product, that would be helpful. But in this case, this is not helpful. So this is not a good idea, but I just wanted to show you, because you don't always get to the solution. Sometimes you try different things and they don't work. Okay, instead of this, let's go ahead and do e to the power both sides. So in other words, if y plus e to the y equals x plus e to the x, then when we do e to the power y plus e to the y, that's going to equal e to the power x plus e to the x. Again, e to the power t is a function, so this works. So sum is turned into a product. Amazing transformation, isn't it? Thank you, Euler. So now we have a sum of exponents, and if you remember, when you multiply a to the power b times a to the power c, it becomes a to the power b plus c, or vice versa. If you have a to the power b plus c, you can write it as a to the b times a to the c. And guess what? You can use this to prove that any number to the power 0 is equal to 1. For example, if you write a to the power b times a to the power 0, that becomes a to the power b plus 0, which is a to the power b. And then by dividing both sides by a to the b, you get a to the power 0 equals 1. Does this work for a equals 0? Of course, it does, right? Many people believe that it does because 0 to the power 0 is equal to 1. But some people, unfortunately, do not believe that 0 to the power 0 is equal to 1. You can go ahead and check out my video. I made a video about 0 to the power 0. All right, great. So let's go ahead and separate these then. We can write this as e to the y times e to the y equals e to the x times e to the x. Does this look like Lambert's W function to you? I hope it does, because we're about to apply it. So basically the idea is, if you apply Lambert's W function to t to the t, your output will be just t. It's also called the product log. Okay, if you wanted to enter this in Wolfram Alpha, just write it as one word, product log, parentheses, whatever you want to evaluate. And sometimes you can indicate the branch, because Lambert's W function has different branches. All right, so this is going to be our mathematical touch. What is the mathematical touch? Substitution, of course. What else can it be, right? So we're going to go ahead and call this e to the y t, and I'm going to call this u. Yes, this is u. Now this gives us the following. Because we call that t e to the t equals u e to the u. And you already got the formula, right? Lambert's W function, the product log, is going to solve the problem. Great. So now we can apply it to both sides. And by the way, I know we don't have a 2, but we could multiply both sides by 2 for a little bit. And if it's your birthday, happy birthday to you. I just wanted to say that. Okay. Now, if you apply Lambert's W function on both sides, what's going to happen? Let's go ahead and move this a little bit, make some room. And now we're going to put W here and W here. And by definition, Wt to the t is just going to turn into t, and Wu to e to the u is just going to be u. So t equals u. What does that mean? What is t? T is e to the power y. Remember that? Did you forget? Okay. E to the y is t. So this means e to the y equals e to the x. Guess what that means? It means y equals x. But why? Because e to the power x is bijective, or 1 to 1. That's why it works. That's interesting, right? And also you can ln both sides here and write this as ln e to the y equals ln e to the power x, because if a is b, a equals b, then ln a equals ln b, for the same reason, right? So y equals x is the conclusion, and remember we were trying to solve for what? Solve for y, and we got it. Y equals x. Nice? You like it? Okay. I'll be showing another method. I don't know if you were expecting it, but I guess I forgot to announce it at the beginning. I forgot to say that I was going to present two methods. So let's call this second method, even though we didn't call the first one first. You get the idea. So we use Lambert's W function, but before that, notice what we did. We did use exponential so that we could turn it into a product, because Lambert's W function can only apply to something that looks like this. Okay? Awesome. What are we going to do for the second method? Do you have any ideas? Okay, here's what we're going to do. We're going to set f of t equal to t plus e to the t. There's a good reason behind it. And the next step is going to be differentiating this function. When you differentiate t, you get 1, right? Just like x, with respect to t, of course. And when you differentiate e to the t is a super special function whose derivative equals itself. Of course, we're differentiating with respect to t. Notice that if t is a real number, e to the t is always positive. 1 plus e to the t is even more positive. You know, Animal Farm, some animals are equal, some others are more equal than others, or something like that. Anyway, some animals are equal, some animals are more equal than others. So that's something like that. And of course, t is a real number, right? Great. So what does that mean? It means f prime is positive. And from a calculus perspective, from a slope of a tangent line perspective, this means f is increasing. Because if you think about it, first derivative gives you the slope of the tangent. And if the slopes of tangents are always positive, that means the function is going up or increasing. So what does that mean? That means that y plus e to the y equals x plus e to the x means f of y equals f of x, because remember, we defined f of t as t plus e to the t. So these are just points, the value of the function at two different points, like t equals y and t equals x. And as you know, this automatically implies y equals x. Why? Because f is increasing, and because of that, f is injective or 1 to 1, which means that, and from here y equals x. So, which means that we got a solution, right? That's the same one, of course. So, basically, injective means, f is injective means, it passes the horizontal line test. Remember, for functions, we have the vertical line test. This is for injectivity, okay? The horizontal line test. For example, if you have y equals x squared, it does not pass the horizontal line test because it's not injective. Make sense? Okay, awesome. Now, if f of x equals x plus e to the x, can you find f inverse? Maybe we'll talk about this in another video. Coming up soon. Keep watching. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.